At the first Software Engineering Daily Meetup, the speakers explored a range of topics. A few weeks ago, we published Courtland Allen's talk about how to build a small software business. In today's episode, we are publishing Haseeb Qureshi's talk, which is called Everything That Rises Must Converge: Why Engineers Disagree About Everything and Why Fraudsters Do Too. This talk explores philosophy, poker, software engineering, fraud, and a basket of other topics. These might seem like a random collection of topics, but Haseeb currently works as an engineer on Airbnb's risk team, and he's also the author of How to Be a Poker Player, which is a book about the philosophy of poker. So he has a lot of experience in this broad range of topics. This audio was taken from the meetup, and we cleaned it up as best that we could. We will do a better job with the audio from the next meetup, which is Thursday, March 9th at Galvanize, by the way. You can check out our meetup page for more details, and I hope you enjoy this episode with Haseeb. When you are continuously deploying software, you need to know how your code changes affect user traffic around the world. Apica system helps companies with their end-user experience, focusing on availability and performance. Test, monitor, and optimize your applications with Apica system. With Apica Zebra Tester, Apica Load Test, and Apica Synthetic, you can ensure that your apps and APIs work for all your users at any time around the world. Apica Zebra Tester provides local load testing for individuals, small teams, and enterprise DevOps teams to get started quickly and scale load testing as your needs evolve. Apica Load Test ensures that your app can serve traffic even under high load. Apica Synthetic sends traffic to your website and your API endpoints from more than 80 different countries, ensuring wide coverage. Right now, you can go to softwareengineeringdaily.com/Apica for a webinar about the real ROI of API testing. You can also find past webinars, such as how to optimize websites for fast load time. Go to softwareengineeringdaily.com/Apica to find the latest webinars on load testing and lots of other topics, and check out Apica system for testing, monitoring, and optimization. Thanks again to Apica for being a sponsor of Software Engineering Daily.
My talk today is going to be something of a change of pace, because. The title of my talk is Everything That Rises Must Converge: Why Engineers Disagree About Everything and Why Fraudsters Do Too. I was writing these slides pretty late last night, and it occurred to me around 1:43 a.m. that my subtitle had a subtitle. I don't know what that means, but it's probably bad. But hopefully this talk will salvage itself. So who am I? Quick show of hands. I mean, you guys presumably listen to the podcast. How many people don't know who I am? Like, do not know? Cool. So they're all, okay, so quite a few people. Okay, so I guess I should introduce myself. So I'm Haseeb Qureshi. I've done a few episodes, been interviewed a couple times on Software Engineering Daily. I've done one episode myself, which is this one, which if you haven't listened to it already, you should, because it's okay. It's pretty good. So I used to be a professional poker player, as Jeff explained. I studied English and philosophy in school, and I had no idea that I was going to end up being a software engineer. I went to a coding boot camp. I actually moved out to San Francisco a little bit under 2 years ago, and I went to a coding boot camp, did a bunch of stuff. Now I work as a software engineer at Airbnb on the risk team. So I'll be talking more about that. I'll be talking more about all that stuff, but that's basically who I am. So in the past, if you've heard, I guess, however many of you raise your hands, I guess haven't heard, but in the past I've talked on a number of different topics on Software Engineering Daily. So I've talked about negotiation, I've talked about the relationship between programming and poker, I've talked about coding boot camps, talked about how to learn, but today I'm not going to talk about any of that crap. So hopefully you weren't expecting me to. Today I want to talk about philosophy. So if you want to sit out this one, that's totally fine. There's a lot of stuff to do out in the lobby. Specifically, I want to talk about epistemology. So epistemology is a subfield within philosophy, and it's basically the study of knowledge. Okay, and the best definition of epistemology is it's the study of the nature of knowledge, justification, and the rationality of belief. Okay, and right here is actually a diagram of Joseph Gall inventing the first Snapchat filter. So I was actually in the 1800s. I'm going to be telling a lot of bad jokes, just so you know. I tested this. They're actually all bad. So just be prepared for that. Okay, so the question under epistemology is, how does anybody know anything? And not just how do they know anything, but how do they know that they know it? Okay. Now, for someone like me, so I've kind of, I'm something of I guess like a chameleon, in that I've kind of wandered through a lot of different worlds, a lot of different subcultures. And I've kind of seen how, things that people say they know differ so much between different cultures, not just like human cultures, but subcultures, like little worlds that you find yourself in, right? And so being a poker player, being a software engineer, working in the fraud industry, right? Like, they're all places where you find, where you really learn how cultural the concept of knowledge really is. So, the sorts of things that I hear that people tell me that they know. They tell me that full stack JavaScript is the future. They know that everybody should know C. That Rust is the best language for systems programming, as we touched on earlier, how best it is. That relational databases don't scale. That TDD is a fantasy and nobody serious actually does it. And I'm not interested in convincing you about any of these claims. They'd probably all be great talks for Software Engineering Daily. Fortunately, this one probably not be. I'm more interested in why people disagree about these things that many people claim to know. So in poker, I remember similar kinds of things, right? People would say, no limit is dying, you've got to learn mixed games. They'd say everybody needs to use a HUD. They would say only fish play loose passive styles. Or they'd say GTO is a fantasy, nobody actually plays like that. And there's a wonderful analogy, I think, in between these worlds, in not just the opinionation and kind of the whininess of people, but also in the conviction with which they hold knowledge, or which they believe they hold knowledge, that not everybody shares, even if they're in the same domain. So when most people hear stuff like this, like, this thing is the future, this thing, everyone needs to know this, I think most people tend to say to themselves, is that true? And if that's true, what should I do about it? Like, I don't know, it's something that causes this anxiety inside of you to know that, oh my God, everyone should know C and I don't know C. But when I hear stuff like this, I ask, how do they know that? Why do they think they know that? And what is it about the way they arrived at that belief that gave them so much conviction in the first place that they know this thing? The weird thing about programming to me is that nobody agrees. Right? There are all these things that people argue about all the time, about object-oriented programming, functional programming, robust old frameworks, shiny new ones, right? People just disagree about almost everything. And you might think, looking at that, you're like, oh, well, of course, there's diversity of opinion. Of course people won't agree. That seems like a normal thing. It seems like a healthy part of, a society, maybe, that people disagree. I think it's weird. I think it's weird that people don't agree. And I want to develop in you an intuition also, why you should feel that's also weird. Because in a way, it makes more sense for people to agree than for them to disagree.
Indeed Prime flips the typical model of job search and makes it easy to apply to multiple jobs and get multiple offers. Indeed Prime simplifies your job search and helps you land that ideal software engineering position from companies like Facebook or Uber or Dropbox. Candidates get immediate exposure to top companies with just one simple application to Indeed Prime. And the companies on Prime's exclusive platform message the candidates with salary and equity up front. Indeed Prime is 100% free for candidates. There are no strings attached. Sign up now and help support Software Engineering Daily by going to Indeed.com/SEDaily. That's Indeed.com/SEDaily if you're looking for a job and want a simpler job search experience. You can also put money in your pocket by referring your friends and colleagues. Refer a software engineer to the platform and get $200 when they get contacted by a company, and $2,000 when they accept a job through Prime. You can learn more about this at Indeed.com/prime/referral. That's Indeed.com/prime/referral for the Indeed referral program. Thanks to Indeed for being a continued sponsor of Software Engineering Daily. If I ever leave the podcasting world and need to find a job once again, Indeed Prime will be my first stop.
Systems tend to converge. When you look at a system, you should assume that it's going to converge on what's optimal. That it will, for better or for worse, it will move in the direction of its optimal state. Let me give you an example. I'm going to use a poker example, but you don't need to know anything about poker in order to understand this. Okay? So in poker, there's a strategy called set mining. Okay? And it's a very simple strategy. I can explain it to you in like a couple sentences. Basically, to set mine, what you do is you try to play pocket pairs. Okay? So basically, if you get dealt a pair, you get dealt 2 cards, make them a pair, and then what you do is you wait to try to make 3 of a kind. And if you make 3 of a kind, you bet it really aggressively, and if you don't, you just fold it. That's set mining. Super, super simple. It was a pretty simple and stupid strategy. It's, almost anybody can do it. And it worked. It worked really, really well. And what you notice is that pretty soon, when people started talking about set mining, and the information started sort of being out there in the world, that almost everybody started set mining at low and mid-stakes full ring games. It was just such a good, easy to implement strategy that almost everybody did it. It sort of spread like wildfire. The game, you could sort of say, it converged on set mining. Everybody saw that set mining was the high ground in this terrain, and they all moved in that direction, and it wasn't that hard to get there, because set mining is a pretty simple strategy. And the thing about poker is that it drills into you. Just to be a poker player, you have to think in terms of always doing the highest EV thing, or the highest expected value thing. In other words, to always do whatever it is that you believe is optimal. So it's very natural for a poker player to do that. One thing that was really interesting to me about poker, because I started playing poker around 2007, which was kind of a little bit after the very peak of online poker in terms of like gaining acceleration and popularity. And the really fascinating thing about online poker to me was, not just like all these young people making all this money and changing the game and whatever. The thing that was really fascinating to me is how it changed poker strategy forever, and how quickly it changed poker strategy. So you can imagine, poker's been a game played since, medieval times or something. And I don't know when it got really popular in the United States, sometime in the late 1800s, 1900s, something like that. And, people were playing poker in the 50s and 60s and 70s and 80s and 90s. They were in card rooms, they were in casinos. But the interesting thing is that, the people who were playing in Dallas didn't really communicate very much with the people who were playing in Vegas. They didn't really communicate much with the people who were playing in London. And people just sort of played in card rooms, they kind of figured out things, and they played poker, and they gambled with each other. And then internet poker came around, and it changed everything, okay? And it didn't just change it that you could just, play poker in your boxers at home and, not get out of the house. It did change that, but the bigger thing that it changed is it changed the way in which this system became open. The way in which people could communicate with each other and see what each other were doing, and it allowed them to coordinate and converge. And what happened was, if you imagine sort of the graph of the complexity of poker strategy, it's flat, it's flat, it's flat, it's flat, it's flat, until about 2004 or 5, and then suddenly it skyrockets in complexity. And suddenly everybody starts to converge on what the optimal strategies are and what the best way to play poker is, where before no one had any idea. There was no way to actually arrive at those strategies. And so this right here is a graph. It's actually nothing particularly, oh, this is really loud. I think I actually mistimed this slide a little bit. I was supposed to switch earlier. This is a graph of absolutely nothing relevant to what I was talking about, but I think it gives you that feeling, right, of like, this guy knows what he's talking about. So the interesting thing was that online poker converged. And it converged in a way that live poker, like playing poker in brick and mortar casinos, could not converge and did not converge. And that's interesting to me. And it makes sense to me that it would do that. And nature is full of convergent systems. So imagine you're in downtown San Francisco and you buy a loaf of bread you don't like. I don't know who's buying loaves of bread. But you buy a loaf of bread, you don't like it, you chew off half of it, you toss it in the street. And not 2 minutes later, it's just, there's a chorus of pigeons surrounding it, right? And the pigeons aren't just all hanging out in one place like a gang, and they don't all, somehow they all converge on the closest piece of food that's just easily accessible, right? And all of the pigeons find themselves around this loaf of bread that you've tossed. And the moment the loaf of bread is gone, they all disperse and they go and find the next best piece of food somewhere in Soma, or I don't know, maybe they hang out somewhere, wherever they hang out, I don't know. Another example is so this is actually, this is a cell wall. I don't know why I chose a German depiction of cell wall. It kind of looks like a Rammstein like album cover, I thought for a second, but it's actually a cell wall. But the idea is that, you probably remember high school chemistry, diffusion, right? So there, these water particles, they eventually diffuse over the cell membrane, and then you get this, again, you get this convergence, right? Where the density of water molecules is the same on each side of the membrane. Same thing you see in markets, same thing you see, lightning striking ground. All of these things are convergent systems. And so when I started working at Airbnb as a risk engineer, I started looking for that same kind of convergence. And I guess let me preface a little bit with what it means to be a risk engineer. So I, kind of like Pete, I also work in the fraud space. So risk encompasses a lot of things at Airbnb. One of the things it encompasses is fraud. So bad actors trying to defraud us either out of money or trying to hurt our users or whatever. So my team works to fight against that and to keep our users safe. But I was always really interested by the world of fraud. Right? I mean, there's a world of engineers fighting fraud, and that's neat. But what was really fascinating to me was the world of the people who are doing the fraud. Because there's a whole subculture, there's a whole culture that's really there, that's really actually there, guiding everything that they're doing. And it's so opaque to us when you're just sort of fighting it from one side and just kind of spraying water from afar. And so this is an artist's depiction of me actually doing fraud engineering. I'm in the hand there. That's people robbing us blind. This is actually a real depiction of my job. I don't know why this slide is in here. So the question that I have when I see the world of fraud is I really want to understand, how do fraudsters make the decisions that they make? How do they know what to do, right? So these fraudsters are going out, they're attacking a lot of these online sites. They're attacking Facebook, Google, Airbnb, Uber, whatever. How do they know that they should attack us? How do they know how to attack us? How do they learn the things they need to learn in order to do it, right? It's pretty non-trivial. And how do they know what they know about our sites, about their weaknesses, about the best places to defraud people? Basically, the question I want to know is there convergence in fraud? I don't know if you guys can see the subtitle here, but this is actually a real photo of the new MacBook Pro. They just have this button on there. I don't know why. MacBook Pro jokes. Doing really well with this crowd. This is the one place I expected a MacBook Pro joke to go well. Yeah, thank you. All right. Okay, so let me give you an example of, just for those of you who don't have much familiarity with the fraud space, this is some site, I don't know what, Chipmunk? I don't know what Chipmunk is. Does anyone know what Chipmunk is? Great. Good. We'll shit all over them. That's great. So Chipmunk is a terrible site. If anyone from Chipmunk is listening to this, should probably be, because we're like potentially going to record this. So Chipmunk's a great site, but sometimes they mess up because they're moving fast and breaking things. So they implement this thing where they want to verify your payment, your payout instrument, right? So you might get paid on Chipmunk. I don't know why. I guess you're receiving shipments or something, I don't know. And so they're going to send micro deposits into your account, 20 cents and then 41 cents, and you got to report those two back, right? Pretty simple, cool, straightforward. The engineers who do this are just engineers who just want to get their job done and, I don't know, fill out a ticket and then get a raise. So the thing they don't do is they don't implement rate limiting, okay? There's a problem. Rate limiting of different kinds, right? So basically, bad actors see this and they just, they lick their lips and they're like, okay, I'm just going to create accounts on Chipmunk at scale. I'm going to keep adding the same bank account on all these different accounts, and I'm just going to keep micro-depositing myself. I'm just going to write some Selenium script that'll do this for me. And then I have, after a day, I've now micro-deposited $100,000 in my account. And this is an attack that's not that uncommon if you implement something like this. You have to defend against this kind of attack. Let's say Chipmunk doesn't do it. So, Chipmunk wakes up the next day and they're like, oh no, we're under attack, someone's doing this. We wake up the most senior person who actually knows how to do stuff, and they go, all right, we're going to rate limit, we're going to turn this thing off, we're going to we're going to do this right. Great. So what happens after this super profitable attack, the thing you note is that usually when a vulnerability like this starts getting exploited, the interesting thing is that it's not just like one person exploiting it, right? Immediately, everybody starts attacking this thing. It's just like a fire that just takes off. And suddenly almost all of the fraud is converging on this weakened endpoint. And it becomes a fire, right? It's very rare that fraud is just sort of like, oh, people are kind of defrauding us, and now they're doing a little bit more, and now they're doing, I guess we got to tell my boss about this, right? That's never how fraud happens. Fraud almost always happens that, oh crap, everything's on fire, we got to go fix this, right? So that's what happens here. And so what happens is, they patch the vulnerability, and the fraudsters all immediately disperse. And where do they disperse to? Like, what do they do now? In all likelihood, they head to the next highest peaks. They go to whatever is the next most vulnerable, most profitable, most worth their time place to attack you. And this makes sense. This is convergent, right? This is what you'd expect out of a convergent system, which is very satisfying to me when I think about that. But the more I thought about this, the more something really bugged me about how this whole thing works. Because the question that I really had is, why are they defrauding us at all? That might sound like a dumb question, right? Of course, they're trying to make money. I'm well aware of that. But there are so many companies out there that you can defraud, right? There's not just one. It's not just Chipmunk, right? Any company that has any significant internet presence is vulnerable to some kind of fraud and some kind of way to make money off of them, right? There's some topology to that fraud where each one of these peaks and valleys or points in space is a company that you can attack. And you'd think that everybody would converge on the peaks, right? So whatever it is, whatever company is sort of the most lucrative to defraud, you'd expect that almost all of the fraud would just be concentrated on those few companies. But that's not what you see. What you see is just this ambient level of fraud everywhere, right? There's like any site of sufficient scale and profitability just starts experiencing fraud. Even if the fraud isn't that lucrative, it's not that crazy, everybody gets some fraud. This is weird. Like, this should strike you as weird. Why is this happening? Do the fraudsters just not care about making money? Do they not care about optimizing their time? Are they misguided? What's going on here? Now, you see the same thing in software, right? And ultimately, I was going to get back to talking about software. But you see the same thing where there are all of these competing things in space to solve your problems, right? All of these different stacks, all these different technologies, all these different databases, right? And there doesn't seem to be a convergence. Software doesn't seem to converge. And when it does, it's pretty surprising, right? We look at something like React and we say, oh, React, depending on who you ask, React won, front-end UIs. And people are like, wow, isn't that crazy? React won? No one ever wins anything anymore. But React won, and that's like really cool, and it calms us down because we're like, oh, cool, I just got to learn React, and then it'll be employable forever, great, right? So you might think, okay, well, I know why software doesn't converge, right? The obvious answer is that, well, software solves multiple problems. It's not the same thing as fraud, where fraud you're just trying to make money by sitting, at your computer and trying to defraud people. Software tries to solve many different kinds of problems. So of course you're not going to get one terrain and one peak and one maximum. So you might say, okay, well, they're CRUD apps, and they have a different terrain, and they're payment backends, and they're a different terrain, social networks, right? And maybe each of these things do have their maxima. But if you try to look for one across the whole terrain, you're misapprehending the actual situation. But the problem is, even within a single terrain, you don't see convergence, right? Who thinks that everyone agrees on how to build CRUD apps? No one thinks that, right? Of course. In fact, no one can disagree more about how to build CRUD apps. It's like the vast majority of what people build, and therefore it's the vast majority of what people disagree on. And so that doesn't seem to me to be satisfactory to explain why we don't see convergence in the world of software. And the thing is, you should want convergence. Convergence means that we all see that underlying terrain. It means we all actually know what is good and what is less good, what is actually useful to us, what is actually optimal. And when we all do that best thing, it's actually good for all of us. Right? Software is a space, unlike poker, or maybe unlike fraud, where we're not all competing with each other. Right? We're actually all kind of in it side by side, and for the most part, it helps us when other people do well. So why do these systems not converge? I think there are 4 reasons, and I'm going to tell you them, in case you're worried. The first reason is that the terrain is unstable. So I think this is especially true in software. Right? You're probably pretty familiar with this, that you learn one framework, it's really awesome, and then a year later, oh my God, React came and blew everything out of the water, I got to unlearn Angular 1.x, everything's changed, right? I don't know how many of you have read this article, it's pretty big, how it feels like to learn JavaScript in 2016. I think most people know what he's talking about even if you don't open this article. Everything changes in software really, really fast, right? And somebody who 5 years ago was like, oh my God, Java is just the best thing to learn, and I need to learn the crap out of Java, and that's the most important thing. And then a few years later, suddenly Java is totally irrelevant. And this makes it hard, of course, if the terrain is constantly changing, to actually stay at a local maximum, because a couple months later, the local maximum dips down, and now suddenly the terrain looks totally different, and it's like, oh, well, crap. I got to figure this new thing out. And the same thing, by the way, happens in the world of fraud. Because in the world of fraud, let's say that Facebook is the best site to defraud right now. Facebook eventually gets beaten with fraud, and they're like, you know what, we should hire a fraud team, and we should batten down the ship. And then they do, and then suddenly all the people who spent all their time learning how to defraud Facebook are kind of shit out of luck. They have all these skills defrauding Facebook, and Facebook is now robust, and you can, instead of making $20 an hour, now you can only make $3 an hour defrauding Facebook. And so that makes it hard for a fraudster to actually move around in this terrain and find the maximum at any given time. So, and of course, when fraudsters, when a hole gets patched, fraudsters dissipate. They disperse. They go find the next thing. And chances are the next thing will be pretty close to them.
Simplify continuous delivery with GoCD, the on-premise, open-source, continuous delivery tool by ThoughtWorks. With GoCD, you can easily model complex deployment workflows using pipelines, and you can visualize them end-to-end with its value stream map. You get complete visibility into and control of your company's deployments. At gocd.io/sedaily, you can find out how to bring continuous delivery to your teams. Say goodbye to deployment panic and hello to consistent, predictable deliveries. Visit gocd.io/sedaily to learn more about GoCD. Commercial support and enterprise add-ons, including disaster recovery, are available. Thank you to GoCD and thank you to ThoughtWorks. I'm a huge fan of ThoughtWorks and their products, including GoCD. And we're fans of continuous delivery, so check out gocd.io/sedaily.
Second reason why I think these systems don't converge. There are high switching costs. So imagine that one of these is Java Island, or Java Mountain, I don't know why it's island, and the other one is, I don't know, something, Haskell, whatever. Whatever. The point is, somebody can convince you all they want that Haskell is the shit. Haskell is the place where all your problems will be solved, everything will be perfect, all the stuff you hate about Java will go away. Well, great, but I have to travel this enormous distance and do all this work and have all these opportunity costs until I can actually get to that high ground. And given that the terrain is changing, that's probably not worth the risk, right? So the fact that the terrain isn't stable and the fact that it's actually very hard to do that switching makes this expensive for me. And makes me unlikely to want to do it. And the same thing, again, happens in the world of fraud. When you become really, really specialized, then it becomes hard for you to learn a whole new set of skills, given how good you are at the old set of skills. It might just take you a really long time to get there, where I can make more than $3 an hour defrauding anybody other than Facebook, even though Facebook is now not that great of a target. Reason number 3, information sharing. Now, this is a big one, right? Various subcultures have various degrees of information sharing. And I think if you were to rank the 3 cultures that I've been describing in this talk, I think it would roughly look like this, where fraud is a very closed system. Fraud is a space where in order to actually learn what are the best sites to defraud, what are the strategies people are using, a lot of times you have to pay money for fraud courses. Actually, fraud has their own sort of Udacity thing, and there are underground courses you can buy on Taobao and places like that. They cost money. People make money from this. It's an industry. But not only that, but in order to actually get into these fraud rings, you have to prove yourself. You have to get legitimacy. You have to have people trust you, right? These are hard things. It's a very closed system. You can't just decide one day, hey, you know what? I'm going to learn about fraud. I'm going to go buy a book from the fraud professor. No such thing. Doesn't work that way. So then poker's kind of an open, kind of a closed system. People share information online, but the very best players and the very best strategies are generally not for sale. And the very best people who have the most information to protect do a reasonably good job of protecting it. And of course, there's a lot of crap out there that's very low quality information that is not very good. And then strangely, software is probably the farthest right on the spectrum you could possibly get, right? Where software is staggeringly open. It's so open to the extent that not only do people write blog posts about their cutting edge technology, even their fraud systems, right, or their security systems, but they even open source all of their software. And so, some bad actor can literally just go through a repository and comb through, okay, I see this weakness, I see that weakness, and then attack you. And people are okay with that, and that's good. It seems like that should ameliorate the problem. somehow it doesn't. Reason number 4 is group identity. And I think this one is really interesting. So you can imagine the space of programming being not just a terrain, but a demarcated terrain. And this makes it a lot more complicated, right? Where now, sure, there's a space around Ruby Mountain, right? But this space around Ruby Mountain is not just, it's not just a space that you can freely traverse. There's a group identity associated with being in that space. It's called being a Rubyist, right? And there's other space for Java lovers, okay? And if you're a Rubyist and you go into Java lover land, it doesn't work out so well. There are kind of soft rules on what you can and can't do if you want to make it in Ruby land that don't fly in Java land. Same thing happens in fraud rings, where there are these group identities. There are groups of people who defraud Uber. That's all they do. They talk on, whatever channels they talk on, I guess WeChat or whatever, and they share information about how to attack Uber. And if you're a Facebook attacker, you don't have access to that. And you kind of can't get access to that because you're just different groups. There's this theory in psychology called social identity theory, okay? And the premise of social identity theory is that a large part of what you think of as yourself, a large part of what makes your identity is your adherence to groups. So this sort of goes in 3 stages. The first stage is what's called social categorization, okay? When you look out in the world, you see just a bunch of people, right? I mean, I look out in this crowd, I see just people. But what you start doing is you start cutting out areas of the terrain. And I say, okay, these people are goths. And these people are losers. And these people are engineers. And these people are, I don't know, weirdos, right? Whatever. You start cutting out these arbitrary categories, right? Start dividing the world into groups. Then you choose which groups you identify with, right? So I decide, okay, I got one foot in here. I'm going to take the goth one. That sounds good. I'm going to meet lovers, whatever. I don't know. And then finally, the last stage is social comparison, right? Now that you have your group identities, now you have to do the work of rejecting other groups and deciding which groups are better than others and why, right? And so you get stuff where, there's this one group that has, I don't know, a star on their belly, and that group is different. Why is that group different? It's not different because of some intrinsic reason. It's different because they decided to draw the boundary right there on whether or not you have a star on your belly, right? And of course, the same thing happens in the world of software. The same thing happens in all of our subcultures, where we distinguish between the in-group and the out-group. And actually blurring that line is very dangerous in maintaining the social identity. There's also this field of psychology, I just want to touch on this briefly, called differential psychology, which basically studies how people differ within the same group. And this is really interesting to me, right? Because if you just take that on its face of like, okay, we all want to belong to the same group, right? So take the folks in West Side Story. You notice they all kind of have a look, right? You can kind of tell, okay, these are all in the same group. But they don't all look exactly the same. And they could. They could all wear exactly the same clothes, but they don't all wear exactly the same clothes, right? Why? Why don't they do that? I mean, wouldn't they have a stronger group identity if they all wore the exact same thing? But they don't, right? And in a way, you actually see that they have a stronger group identity because they assert these small differences among each other in order to differentiate themselves, but still maintain membership in this group, right? And in a way, it would actually be, if you can imagine like you and your closest friends all wearing the same clothes all the time, and going to the same places every night, it would actually be really uncomfortable, right? Like there's something really creepy about that. And it's not just creepy because people would think it's creepy, but it's creepy because you kind of lose something about what it means to be a part of that group if you totally don't differentiate yourself from the other members, right? And so you get this dynamic where not only is the external group bad, but then inside the group we have to differentiate ourselves in order to maintain our identities, right? And this sort of behavior, I think, is what leads to a lot of this siloing that you end up seeing, this balkanization of the worlds of fraud, the worlds of engineering, the worlds of almost any subculture. Now, what I want to say is that we should want to find what really is the optimum, what really is the peak in this terrain that we're traversing. So I want to end my talk on the note of answering the question of, what does it matter that this is the case, and what should we do about it if we want to fight against this collective delusion of these differences and these group identities and this inability to actually see clearly the terrain. So I guess I have 2 pieces of advice that I want to leave this talk with, because it would potentially feel unsatisfying if I just ended it here, even though I'm probably over time. The first one you might have heard before. Paul Graham famously stated this: keep your identity small. what that means is let go of your group identities. Be willing to muddy the water of who you are and what you believe most deeply about what makes you who you are. Be willing to explore different things than the things that you think are intrinsic to you. And that's really uncomfortable. And it should be uncomfortable. And if it doesn't make you uncomfortable, you're probably not actually doing it. So that's the first thing that I want to say. The second thing I want to say, and probably the most important one, is explore. Like, really be willing to move across the terrain and to take risks. So if you imagine yourself probably, given that you're in a stable place, given that you're doing what you're doing, you're probably on a local peak somewhere, right? And I like to think about it as sort of an exploration problem. Most people don't explore enough. Most people just hill climb immediately where they are, they sit at a peak and they stay there. And almost always what's going to happen to you, because the terrain is moving, is that the place that you think was a peak at the time that you started traversing up that hill is no longer a peak. It's not even close to a peak. And the only way that you're going to break that is by continuing to explore. So that's my talk. My name is Haseeb. Thanks for listening. I appreciate it.
A few things before we go. If you like the music on Software Engineering Daily, you might like my most recent album called Commodity, which features a lot of the songs that air on this podcast. My artist name is The Prion, that's Prion, on Spotify, Apple Music, and Amazon. Also, Software Engineering Daily is having our second meetup, March 9th at Galvanize. You can find details on our meetup page. And finally, we are about to post our second listener survey, which is available on softwareengineeringdaily.com. This is your opportunity to have your voice heard and let us know how we can improve. This data is super valuable to us, and we look at every single response. So please take the listener survey at softwareengineeringdaily.com. Thanks for listening to all these announcements. We'll see you next time on Software Engineering Daily.